So today's lesson is on exponential functions. So we have three essential questions. What is the equation of an exponential function? What is exponential growth and decay, and how do we graph exponential functions? So here is the equation of an exponential function. Notice here that the variable x is in the exponent. Whenever you have a variable in the exponent, it's an exponential function. Our a is our coefficient and our b is our base. Now notice we have an a, an h, and a k. Remember, a is either stretch or compress. If it's a negative sign in front, remember it's reflect across the x-axis. Our h is move left or right, and our k is move up or down. Those are still the same. So it's the same no matter which function we have. The function just looks differently in every single case. We have a couple rules here. A cannot equal 0. Why? Because if you have 0 times anything, it equals 0. That means this whole thing would equal 0, and we wouldn't have an exponential function anymore because this x in the exponent would just cancel out if a was 0. B has to be greater than 0, and also b cannot be 1. 1 raised to anything, so if we had like 1 to the 5th power, that's 1. 1 to the 6th power, that's 1. Any number, 1 to any power equals 1. And if this whole thing, if this was a 1, we wouldn't have an exponential function anymore. We wouldn't have an exponent. So b cannot also be 1. So let's take a look at the graph of an exponential function. This is the parent function. 2 to the x power is the parent function. It kind of looks like this, doesn't it? Do you notice how on the parent function for the exponential, the x is in the exponent, right? And here the x is in the base, but you see how there's a 2 and an x in both of these? So our exponential function kind of looks similar to our quadratic. In terms of the parent function, it's just swapped. So now the exponent is in the, our x is in the exponent, our variable is in the exponent. Okay, let's graph. So let's use these 5 points, and let's plug in -2 for x here. If we plug in -2 for x, it's going to be 2 to the -2 power. We plugged in -2 for x. Why did I choose these points? I felt like these are the easiest 5 points to plug into something like this. That's why I chose those. And I wanted to also show you negative. So there's nothing really special necessarily about these points, except they're the easiest to plug in. Okay, and these are the 5 points that I would start with if I was going to graph this any parent function. I would always start with these. Okay, so 2 to the -2 power. Anytime you have a negative exponent, this whole thing moves to the denominator. So you see how you had a -2? This doesn't mean it's a negative number. This -2 means we need to put this whole thing in the denominator. It needs to move down. So 2 to the -2, we can never leave a negative exponent, so we have to make it positive by moving it to the denominator. So now it's 2 to the +2. Well, 2 squared is 4, so 1/4. That's our answer for -2. Now if we plugged in -1, in the same way to make this -1 a +1, because we always need to have positive exponents, we're going to move it down. We're going to move it to the denominator. So our 2 to the -1 turned into 2 to the +1 when we moved it in the denominator. Well, 2 to the 1st power is just 2. So when we plugged in -1, we got 1/2 for our answer. Okay, when we plugged in 0 for x, any number to the 0 power, it doesn't matter what number it is, any number to the 0 power is always 1. So 0, 1. If we plug in 1, well, 2 to the 1st power is just 2. And if we plug in 2, 2 squared is 4. So now we have our table here. And now we're going to graph it. So -2, -1, or +1/4, -2, remember always do x first, and you're going to go up 1/4 of a point. That's the best I could do. 1/4 is in between 0 and 1, so I'm just going to put it right there. Okay, now we have to graph 1, -1, 1/2, so -1, 1/2, 0, 1, 0, 1, make a point, 1, 2, and 2, 4. So that's what our exponential, our parent function of an exponential looks like. Now notice, do you see it here? It's never going to touch this line. If I plugged in a -3, for example, so if I plugged in a -3, which would be over here, it'd be 2 to the -3. And remember, when we have a negative exponent like that, we have to move it to the bottom. So it'd be 1 over 2 to the +3. Well, what's 2 times 2 times 2? 8. So that would be 1/8, right? So this number, if the bigger negative we get, actually the smaller y value we get, but we're never gonna hit 0. So this is called our horizontal asymptote. And we have a horizontal asymptote on our parent function at y equals 0 because it's going to get really, 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 really close to 0, but it's never going to touch 0. You're just going to keep getting fractions that are closer and closer to 0. Our domain. Now, our domain is all of the x values. Is there any x value, if we traced our finger from the very left to the very right, all the way here, we're going to have our function. There's never going to be a place in the x where it can't equal. So it's going to be from -infinity to infinity. Our range is our y. So if we start down here, see how the graph's never going to be below this horizontal asymptote? So it's going to be from 0 all the way into infinity. Our y is only going to be from 0 to infinity. Okay, so let's talk about the transformations of an exponential function. So again, they're all the same. That's our function of an exponential. If we have an x minus h, you go right h units. X plus is left. If we have a positive k, it's up that many units, and if we have a negative k, it's down that many units. If a is greater than 1, if this number is greater than 1, we stretch, and if it's less than 1, if it's in between 0 and 1, we compress. If a equals 1, we neither stretch or compress. We don't do either one. If this is just a 1, we don't have to say stretch or compress because it doesn't stretch or compress. If a is negative, we have an x-axis reflection. Okay, so all of these you're already used to. We have done this many times. But let's take a note on these. If h equals 0, a is the y-intercept. So if we have h equals 0, so if this doesn't exist, so let's just say we have a function that looks like this. F of x equals, I don't know, let's just say 6 to the x. Do you see here how I plugged in 6 for b? And I didn't plug in anything for the h. Like if I had x minus 2, that would be I plugged in something for the h. But I just have 6 to the x power. That means that we don't have an h, right? H is 0. That means that a is the y-intercept. So whatever number a is here, that's the y-intercept. In this case, a is 1. There's nothing outside of that 6, so it's 1. But maybe if I put like a 3 or something, that means since I don't have a minus or plus here for h, that means my y-intercept is going to be 3. 0, 3. Okay? And we'll talk about that more, but I just wanted to show what that looked like. Okay, so let's talk about exponential growth and decay. If b is in between 0 and 1, if this number is in between 0 and 1, it's going to be exponential decay. And this is what exponential decay looks like. We get bigger and bigger and bigger, and then we get really small. It's decaying. Okay? For example, when we talk about something in between 0 and 1, we're talking about 1/2, 3/5, 3/4, etc. All of these numbers are in between 0 and 1. If b is greater than 1, we're talking about exponential growth, and this is what exponential growth looks like. We start really small and we get really big really quick. Okay. For example, 5/4, notice this is still a fraction, just like this, but when the numerator is greater than the denominator, that means it's going to be greater than 1. So if b is greater than 1, it could be 5/4, 3, 8, etc. Then we have exponential growth. So we're going to do 4 examples here. Describe the transformations: growth or decay, horizontal asymptote, domain, range, and y-intercept. So let's start with this one. Okay, the first thing we're going to do is the transformations. So this is a function, y equals 4 to the x plus 2 minus 1. This x plus 2 means we go left 2 units. That minus 1 means we go down 1 unit. And it's exponential growth because our b is 4, and that's greater than 1. Okay, this -1 is our horizontal asymptote at y equals -1. Domain is -infinity to infinity. Range, -1, our horizontal asymptote to infinity. Y-intercept, okay, remember how I said in the previous page that if h is 0, then our y-intercept is going to equal a, right? But our h isn't 0 this time, so this is how we figure out our y-intercept. We're going to set x equal to 0. So this number up here, we're going to make a 0. So it's going to be 4 to the 0 plus 2. See how I plugged in 0 for x to my function? Well, 0 plus 2 is 2. So 4 squared is 16 minus 1 is 15. That means my y-intercept again, I find by setting x equal to 0, is 15. So 0, 15 is my y-intercept. Okay, number 2. Okay, so let's talk about this 12 first. That 12, this is our a term, right? We didn't have an a term here. This was b, and then x minus h plus k, right? We didn't have an a. Our a was 1 here. This time we have an a, this is our b, and we don't have an h or a k term, okay? So this 12 means stretch. That 0.25, since it's in between 0 and 1, it's exponential decay. We have a horizontal asymptote at y equals 0 because there's no k term. Whatever our k is, that's our horizontal asymptote. So horizontal asymptote at y equals -1, horizontal asymptote at y equals 0. There's no k. Our domain is -infinity to infinity. Our range is whatever our horizontal asymptote is to infinity. Okay, and then we have a y-intercept at 0, 12. Why can I just say that we have a y-intercept at 0, 12? Because there's no h term. Remember I said your y-intercept is at 12, or at this a term, when we don't have any h. We don't have a plus or a minus h term here, so our y-intercept is 0, 12. Okay, because h is 0. Number 3. We compress because of that 1/2. So we're going to compress. That 4 tells us exponential growth because this is greater than 1. Horizontal asymptote, y equals, I think I just put 3. That should be y equals -3. Oops. Y equals -3. I'm going to rewrite that. Okay. We have a domain from -infinity to infinity. Our range is -3 to infinity. Remember, we always use this for our range, whatever our horizontal asymptote is, and then we use that also for our range. Y-intercept. We can say our y-intercept is our a term because there's no plus or minus h. This is a k, right? There's no plus or minus h, so our y-intercept is 0, 1/2 because h is 0. Okay, number 4. So that x plus 2 tells us left 2 units. Okay, that -4 down 2 units. And see that 3 tells us exponential growth, but we have a reflection over the x-axis because of that negative. That doesn't mean, so remember the negative is always looked at separately. So the negative tells us reflect, but that 3 is greater than 1. So the negative is separate. The 3 is greater than 1, so it means exponential growth. So our horizontal asymptote here is -4. Domain, -infinity to infinity. Now look at our range. Our range is different this time. Why? Because we have a reflection over the x-axis, which means instead of going from -4 to infinity, we're going to go from -infinity to -4. Because instead of being like this or like this for the graph, it's going to be going the other way. And I'll show you that on Desmos. Or you can plug this in on Desmos and see how the difference between this when it's a negative and like one of these when your A is positive. Y-intercept, you have to plug in 0 for x because see how our k, we have a k term this time. So we're going to plug in 0 for x, just like over here how we had a k term. I'm sorry, an h term, x minus h term. This is x minus h term. We have to plug in 0 for x. So we have -3 to the 0 plus 2. And then -3 squared is -9. Minus 4 is -13. By the way, the reason it's -9 and not +9 is because the negative is outside, it's part of the, see how over here how I said the negative is separate from this 3? So it's saying it's a negative, a negative and then 3 squared separately. So 3 squared is 9, but it's the opposite of it, it's -9 because of this negative up here, because it was part of the problem and we look at it separately. So that means our y-intercept here is 0, -13. Okay, now we're going to try graphing one, and this is the last thing. So it says graph this equation by finding the y-intercept and one other point. What's the y-intercept here? H is 0, isn't it? So our y-intercept is our A. That means we could say our y-intercept is 4 because the A is 4 and our H is 0. There's no H term. So let's graph that. So 0, 4 is right there. I'm going to plug in 1 for my x because that's easiest. So if I plug in 1 for x, 2 to the first power, we have to do exponents first. 2 to the first power is 2. And then 4 times 2 here is 8. So when I plugged in 1 for x, I got 8 for y. So 1, 8 is all the way up here. And then I'm going to graph it. Okay, and then that's it.